Hello, welcome to a quick showcase and implementation tutorial for my Smart Occlusion Highlighter material. This is available on the Fab Marketplace, link in the description. This occlusion highlighter material is applied through a post-process volume and assigned dynamically. It will automatically detect when designated actors are obstructed from the player's vision and assign a highlighter color based on a simple custom depth stencil value on any mesh or skeletal mesh. This means that adding it to your project does not require any modifications or replacing materials on any meshes, objects, or environments. For the tutorial here, I'll be following the steps in the documentation, which I have included with my product listing. Everything is extremely simple and easy to implement, and this will only take a few minutes. So here we go with just using a standard Unreal Engine template for the demonstration here. Alright, so we're in a top-down template here, just one of the standard templates included with Unreal Engine. So step one is to add a post-process volume to the level. So we can go here and go to volumes, and then you would go ahead and find post-process volume. However, if the level already has a post-process volume, it's not necessary to add a second one. So we can just navigate up here to lighting, for example, in this template demo here. And you should find the post-process volume here by default. So we can go ahead and select this one. So what we're going to do is over here in the details panel, we're going to go here to the rendering features, post-process materials, and we're going to add an array element. From here we'll go ahead and choose, and we'll go asset reference, and since we know that we've imported our Smart Occlusion highlighter from the Epic Marketplace, we know that we have the material available in here, both the base material and the material instance. You can use either one here, but it's usually a little bit easier to work with material instances. So we'll go ahead and just assign that one. So we can go MI Occlusion highlighter. So we can go ahead and just assign that. Let's go ahead and save now. And another thing we want to double check here while we're in our post-process volumes details is that it's enabled is set to true, and infinite extent unbound is also set to true. We're going to head into any actor blueprint where we want to apply the occlusion highlighter material dynamically. So for in this case, we can just go ahead and utilize the included top-down character. So what we're going to do is navigate to the character's mesh, or in this case, skeletal mesh, but this works for either static mesh or skeletal mesh. And what we're going to do here is just go custom depth. You can search this in the details, and you'll easily get access to these settings here. So what we need to do is set render custom depth pass to true, and we'll give custom depth stencil value of 1. And here's where you can decide if you want it to be 1 or 2. 1 would be what I've designated as the friendly color, and 2 would be what I've designated as the enemy color, but basically, A or B. So now the next thing we need to do is head to our project settings. And once again, you can just go ahead and go custom depth, easy to search and find these settings just like that. So what we need to do is go ahead and switch the custom depth stencil pass. Needs to be enabled is not good enough. We need enabled with stencil. Very important. And then right down here, you'll have another setting, for custom depth with temporal AA jitter. You'll want that checked as well. That one should be checked to true by default, but once again, just make sure to go ahead and double check that. And we could go ahead and, if you'd like the anti-aliasing method, you could change it to TAA, although this is just kind of an optional thing. You can leave it how it is, or play around with some of those settings if you'd like. So now at this point, that's as simple as that. The material should be applied to our character when we play an editor here, and it should detect if it's occluded from vision behind any object or whatever, and automatically just apply the material. So let's go ahead and see if that's working. So we'll want to move our character behind something. There we go. And as we can see, it is definitely working. So the only issue is right now it is technically statically applied to our character. So if we wanted it to only be activated and deactivated at runtime dynamically, that's where the next steps come in, which is going to be our Occlusion Detection System. So we'll go ahead and open our content folder again, and we'll go to the Smart Occlusion Highlighter folder again. And this time, instead of our material, we'll open up the detection system. And here we have this blueprint. just open up this. This doesn't really do anything right now. It's just a set of code that you can go ahead and copy and paste into any blueprint that you want. And in this case, I have it attached to just the begin play, which you could have this event firing off of anything, but having it on the begin play is totally fine because you basically want this to be enabled right away as soon as any of this actor is active anyways, right? So in this case, the actor that we want this to be applied to, the detection system, would be our top-down character. So we can just go back to our top-down character and into the graph, and you can see right now there's absolutely no logic in here at all whatsoever. We're just going off of the template, and we'll just copy what we did from the occlusion detection blueprint, and then we'll go ahead and paste. And now you can see we have all this in here. Everything is labeled for your convenience so you can know what might need to be adjusted. We'll take a quick look here at all these options. But first of all, this is what's setting the rate of how often this event is going to tick in your project. So you can adjust the time here if you'd like it to be ticking less frequent or more frequent. That's up to you. And here, the line trace. So first of all, you need to double check the start and end of the line trace. The start of the line trace should be the player's camera. So in this case, the camera is attached to the character. So we have the camera reference there in the get world location, and the location of the actor that we're drawing the trace to detect if there's anything occluding the vision. In this case, would just be self because we have it within the character's blueprint. Next thing, we'll go ahead and double check that the trace channel is set to visibility. This is totally fine for most projects. By default, most things are going to have visibility trace channel on block in their occlusion settings, which will go ahead and trigger this. It'll detect a block and go ahead and trigger this. But you can go ahead and set up a custom trace channel if you'd like, and just make sure that it's only detecting collisions and occlusions with certain specified objects in your level. So you can customize it in that way if you'd like. But for now, for the demonstration and for most purposes, visibility will be fine because standard all meshes and stuff have visibility on block. So from there, it's going to detect did we get an obstruction, and if true, then we're going to go ahead and turn on that custom depth, and if not, then we're going to turn it off. And lastly, we'll take a look at this reference right here, which is to the character's mesh, which once again could be either a static mesh or skeletal mesh, which in this case is a skeletal mesh. So we're good to go. And we're going to need to, before we can compile and save, we're going to go ahead and right click and create variable for this Boolean here, view obstructed. So it automatically just adds it to our variables here, and everything compiles and saves with no problem. All right, and last thing that we need to do, since this is now going to be turning on and off dynamically, is we'll go back to our mesh, and once again, we can just easily search custom depth. And now we're going to go ahead and turn off render custom depth pass. But make sure we leave the stencil value at 1 or 2, whatever you want it to be for a friendly or enemy. Make sure that that's still set, but then we're going to go ahead and turn this to false because it's going to be turning true and false dynamically now at runtime based on if it detects an occlusion from the vision. So there we go. Now we can just double check everything's compiled and saved. And at this point, everything should be completely, fully functional. So we can go ahead and once again, play an editor and just verify that we're looking good here. So as you can see, this one has a little bit of a delay involved because we're running the detection system. So it's really up to you if you want to run the detection system at runtime or not. I just wanted to make sure that there were options catered to different setups, however you want to make it run for your project. So, and just to further demonstrate this, we can really quickly just let's go ahead and go up here, add a shape. Let's add a cube, and let's see, let's just put this cube down in the level somewhere here. All right, and then let's go ahead and just make it like basically like as if it's a wall. All right, something simple like that. Cool. So now let's go ahead and just make a new blueprint here, just real quick. We're just going to go actor blueprint, and we're just going to go BP testing enemy. All right, just to see how it works with another actor that you might want to set the secondary stencil value. So we'll go ahead and just add a we'll just add a cube, so you can see it also works with a static mesh here. So cube, and once again we just go custom depth on our cube mesh here, enable that, and this time let's go ahead and give the stencil value of 2 so we can see the enemy coloring there. And that's all we need to do now. Since everything's set up, it's literally that simple. If we wanted to, we could add the runtime detection system into this as well. But for now, you can see, you know, it already works even without adding in the logic of the occlusion detection system dynamically. So just like we saw with our initial test, even on the character. So if it's behind the wall, it's got the material, and if not, so, and you can see how simple that is. It's literally that simple now. We just apply that any actor, any mesh, just go custom depth, turn this on, and apply 1 or 2 for whichever color you want, and then, you know, optionally you can add the detection system for the runtime. And you know, we can just see, like, now we have our, this is our character with the stencil value of 1, and this is our cube that we just quickly made, actor cube with the stencil value of 2. And lastly, I'll go ahead and show you guys how you can quickly modify the material. There's a couple options for that. We'll quickly check that out. So let's go ahead and go back to our Smart Occlusion highlighter in the content browser and open the highlighter material, and then we can open up the material instance, which we have applied to our post-process volume, remember. So over here in the details, we have parameters for enemy color and friendly color, so we can easily just say, I don't know, we want to make this like pink, and say, you know, we want to make this green. There we go, just save, and simple as that. We can verify that, you know, we can see now that our friendly character has the green color, and the enemy cube has the pink color. So it's that easy to go ahead and change the colors of the assigned stencil values. And furthermore, if we want to try to change a little bit of the styling here of what it looks like, we can go ahead and open up our base material, not the material instance, but the base material occlusion highlighter. And what we're going to do is just go in here to the details of the material overall, and go to the search bar here and just type in blendable. And we're going to find this option pop up here, blendable location. You can switch it between scene color, right? It'll be set as scene color before DOF as the standard, which is what you're seeing in the demo. And you can also choose scene color after DOF, not much difference between those. But if you would like, you can also try translucency after DOF. The rest of these options do not really work well. I only recommend really using these top 3 options. These ones are all clean for sure. I've tested them out. So we'll go ahead and choose translucency after DOF so you can see what that looks like, for example. So let's go ahead and run it again. And you can see it's a little bit different now. So it's got a little bit of a different vibe coming through here for the material. If we change it between translucency after DOF, and just so you can see the scene color after DOF, pretty much the same as scene color before DOF. So as you can see, it's a slight difference. The translucency one is a little more, you know, translucent see-through kind of vibe, and this one's a little more solid. So anyways, I hope this quick showcase and tutorial helped you with all the information that you need to implement this into your project, and hopefully you can see how you can scale it up and utilize it without any issues as much as you'd like. Documentation is all comprehensive and fully written out, which is included in the product listing and whatnot too. So once again, the link to this on the Fab Marketplace is included in the description as well. So thank you guys so much, and hope to see you in the next one. All right, peace.